Hello, good afternoon, and welcome everyone. My name is Jeremy Leffler, and I work in the policy office at the National Science Foundation, and it's my pleasure to welcome you today to the Spring 2021 NSF Virtual Grants Conference. So I'm now pleased to present this session, which will cover the programs in the Directorate for Engineering, and we'll see you in a little bit for questions.
Hi, welcome everybody. My name is Brady-Estevez. I'm a program director at NSF Engineering, and I just want to thank you all for coming today. We really come to work as program directors because we're excited about the work you do. So I hope today's presentation, while I realize it'll be high level, can help you see where NSF Engineering might be supportive of your exciting work and your goals. So unfortunately, with the time available, we're not going to be able to dive into great depth into any of these programs. And I only represent one solicitation, but we are going to try to have the goal be to give you an overview of what types of programs we fund. And there are many that we don't touch upon here, but just kind of some of those frames of different areas of research and innovation and science and fundamental research that we do fund, so that you can see where your interests might align with current opportunities. And there'll be plenty of opportunity to see also where in our organization some of those opportunities might reside. And we hope that'll be helpful. In follow-up, you probably will want to reach out to the specific program directors, and because they'll be best suited to give you in-depth information on the programs, or looking at first the information on the solicitations online in any webinars that might be posted or other materials online about how to engage. But we'll also have Q&A after the presentation. So thank you for joining us. So we're your National Science Foundation, and engineering is really here for your work and to support you really in supporting the nation. So just to share a little bit about why we're here and why our mission is closely aligned with your mission. So the NSF's mission as your National Science Foundation is to be supportive of being the nation that is the global leader in research and innovation. So we were established by Congress back in 1950 precisely to have that leadership in science and engineering. And engineering was founded, the Directorate of Engineering was founded 40 years ago. So why did Congress care to set up the agency? And the answer is to promote the progress of science, to advance the national health, prosperity, and welfare, to ensure and secure the national defense, and for other purposes. So fundamentally, the work you're doing is very important to our nation. And it's important to NSF because we're aligning with you in making the nation and hopefully the world a better place. So the goals that we really focus on are expanding knowledge in science, engineering, and learning. And that also includes having a highly capable and diverse workforce in science, technology, engineering, and math. Advancing the nation's capability to meet current and future challenges. Much of what we do with you is really focused on some of the most compelling opportunities and challenges that need to be worked through. And then we also try to enhance the performance of NSF's mission, which, as I stated, is really quite broad. We are the only agency that is set up to fund fundamental research across all areas of science, technology, engineering, and math. And we fund in a wide range of ways, from individual researchers to centers to labs, foundational research to even commercialization and startups. So we're really looking forward to sharing with you some of the opportunities that we hope you are able to take advantage of. And there will definitely be questions both in the future that you can ask about how to best position yourself for funding, and we'll also try to address that at a high level at the end of the presentation. So engineering funds a wide range of impacts. So these range from things like education. Engineering for Us All is one example. So that's a national high school engineering curriculum, which also trains teachers, to foundational research such as patents in additive manufacturing, including 3D printing. This that started off with NSF funding, also to companies that are translating research to practice and commercialization. One recent example that we supported over several years is Ginkgo Bioworks. You might have seen recently in the news that Ginkgo just had a public offering that was over 17 billion. They've been very active in a wide range of biological production of a variety of pharmaceuticals, agricultural products, and food products. So that came out of the synthetic biology ERC, and it has also received prior SBIR, STTR awards. So other examples of centers in teaching, engineering research centers. And as we think about how engineering can be useful to you, we want to focus really on where might your interest be? How can we be relevant to your work? So to share some of the differences and types of things that we fund, so there's looking through the framing of scale. So we fund research and projects ranging from the single investigator to mid-sized teams to centers and networks. Breadth, it can be a very focused single discipline through convergence research that brings together many disciplines. Career stage, we fund whether it's at the undergraduate, sometimes even high school level, to graduate and postdoc, then also to early, mid, and then later career awards. And then the innovation cycle. So we fund the most basic fundamental research. We also fund translated research to the extent that it's in the markets through some of our later stage programs. So a main message to take away here is we fund fundamental research and applied research, and it can be either curiosity driven in terms of where the ideas come from, or something that's very use inspired. So we will continue to be active in funding across these different ranges. So engineering by the numbers, sharing from FY19 as the FY20 numbers will be coming out shortly. It's just under $1 billion of funding in engineering. And as you can see, there's support of a large number of researchers, and we received many different proposals. So we welcome your proposals and would share that we are highly active in this area. In terms of cross-NSF opportunities for engineering, we can also share our NSF 10 big ideas. So we're halfway through these 5-year investment plans, and you'll see there's many of the big ideas, big technology challenges presented here. So whether it's spanning from harnessing the data revolution to the future of work at the human technology frontier, which we've clearly seen some changes this year, to quantum technology, where there's potential for significant gains, to navigating the new Arctic. There's many big initiatives here, and we are halfway through, and some of your ideas might align with these 10 big ideas. So future of work at the human technology frontier. We've had a number of workshops to inform the 2021, and we've looked at things such as restructuring the physical and virtual workspace, exploring human technology partnerships, reskilling, upskilling, and lifelong learning, and then ethical implications for policy. So this is basically focused on those challenges and opportunities for the future of jobs and workers, considering the rapid social and technological changes. Navigating the new Arctic. Many of you are familiar with the potential importance of the new Arctic. In 2020, we funded 17 projects at about 26 million. And this is basically focused on a third of what is envisioned to be at least a 5-year agency-wide program to support the research and dissemination of new knowledge needed to inform the economy, security, and resilience of the nation, the larger Arctic region, and the globe with respect to Arctic change. Mid-scale research infrastructure, clearly at a point where infrastructure is important and thinking about the future of infrastructure. Some of this is quite focused on the incorporation of distributed resources and renewables. So there was a grid-connected testing infrastructure for networked control of distributed energy resources that will provide unique open access assets with potential to advance the integration of renewables and distributed energy resources into the power grids of the future. So this is based at the University of California, San Diego. The test bed will incorporate real-time data analytics, machine learning, and distributed control algorithms. So there's opportunities at this facility to have outreach to students and even teachers and throughout the K-12 schools and community colleges, as well as offering training to Native American communities. The NSF Convergence Accelerator. So this is really focused on use-inspired and application-oriented research, and it's fed by basic research and discovery. So it's taking that convergent approach, integrating teams, including industry, academics, not-for-profits, government entities, and others. So it's a fixed term with a focus on deliverables, and there's quite a bit of education and mentorship involved. So we hope that you might have interest or see opportunities at these interdisciplinary cross-section of fields where it comes together. In 2020, we had a section on quantum technology, and then also an AI-driven innovation. And then in 2021, we're looking at the networked blue economy, so the oceans, and trust and authenticity in communication systems, which is increasingly important in the data economy. Advanced wireless. So there's a spectrum initiative which will advance critical areas to making future wireless and networks faster, smarter, more responsive, and more robust. So advancing areas critical to future generations of wireless technology and networks beyond 5G, IoT, and other forthcoming systems and technologies, really to make the system faster, smarter, more responsive, and more robust. So this includes new wireless sensors, devices, circuits, protocols, networks, and systems. AI and inference on mobile devices, human-machine network interactions, dynamic spectrum allocation and sharing, and integration with infrastructure systems and IoT. The National Radio Dynamic Zones, this is establishing a new pilot test ranges and enhancing existing test facilities to allow dynamic spectrum sharing for passive and active users. Artificial intelligence research institutes. So to expand the frontiers of AI and to create transformational technologies and breakthroughs benefiting both science and society. So here there's focus on a number of evolving and emerging areas, including machine learning, natural language processing, knowledge representation and reasoning, and computer vision, safety, security, robustness, and explainability of AI systems. So this has potential to cover a range of sectors which have been assessed, including agriculture, manufacturing, transportation, personalized medicine, power, investment in education and learning, and also developing the next generation of AI researchers and practitioners. So this is a joint program with several other agencies, and the research institutes are 5 years, so it's $20 million of funding across 5 years. Biotechnology. So the focus here is really on understanding and harnessing biological processes, enabling future innovations in therapeutics, biopharmaceuticals, biochemicals, and biotechnology industries. So in FY21, focusing on areas such as designing synthetic cells, reproducible cells and organisms, understanding the rules of life, whether it's emergent networks or also microbiome interactions and mechanisms. Future of manufacturing. So this is a research grant, 5 years, $500K to $2 million per year on these grants. So these are fundamental, interdisciplinary, multidisciplinary, and integrative research and education. There's also seed grants that are 2 years at $250K a year that are focused on team building, concept development, and research initiation, leading to future proposals. Additionally, there's future manufacturing networks that are 5 years for $500K totals, and this forms communities of researchers, educators, and stakeholders. So some of the areas of focus have been biomanufacturing, cyber manufacturing, and eco-manufacturing. Quantum science and engineering. Initiatives to design devices, applications, tools, or systems with a quantum-based advantage over classical counterparts. So there's been a number of workshops recently, and the program is focused on also the scope of multidisciplinary centers for quantum research and education, as described in the National Quantum Initiative Act. The institutes are expected to foster multidisciplinary approaches. And some of the goals here are quantum sensors that can measure everything from radiation levels to the effects of gravity. There's an institute led by the University of Colorado, which will design, build, and employ quantum sensing technology for a wide range of applications of precision measurement. The Quantum Leap Challenge, this is developing more robust quantum processors, and the institute is led by the University of Illinois Urbana-Champaign, focused on interconnected networks of small-scale quantum processors. There's also a focus on workshop series on the future of semiconductors and beyond. Semiconductors are the foundation for AI, advanced wireless, biotech, and quantum manufacturing. So here we look to identify challenges in semiconductor innovation and manufacturing ecosystems, infrastructure and workforce, and to develop a vision for the future innovations that might be possible. So there have been a variety of workshops, as you can see here, but if your research is focused on these spaces, we want to share our activity, and please think of us with regards to this initiative and the others that I've mentioned. This has been a year that most of us, or many of us, have been affected by COVID-19. Engineering has also focused on funding quite a bit of COVID-related research, and many of those initiatives are actually showing some help to the initiatives and some results. So as a few highlights, Lucera Health succeeded in creating the first FDA-approved at-home COVID-19 device. They had 2 employees at the time of the NSF award, now have 57. And the company's raised over $100 million in private capital and has filed for an IPO. Princeton University has done quite a bit of fundamental research to understand and mitigate the transmission of COVID-19. And there's been quite a bit of work on that in this regard. So to move on and share engineering directorate opportunities, we have a variety of different funding mechanisms. So we have core and unsolicited funding mechanisms. So these are 2 to 4 years, and individual and small collaborative teams, and then funds increase with the collaboration. The solicitations can be a small to a large funding size. Multiple divisions and directorates can be involved depending on the opportunity. So there can be special research and education calls, research, instrumentation and infrastructure, centers and networks. We also hold workshops and conferences, so that's a great way to identify future research opportunities, form collaborative teams, build research and education capacity, and other objectives. DCLs, so these are special opportunities for funding that you might see posted alongside our current programs. So unsolicited proposals to the engineering core. When we engage you as innovators, we're really excited to hear what your ideas are. And they can be in areas that we haven't defined. So PIs, you really have the opportunity to think creatively about proposed work. Think about how you want to build those collaborations. You might have opportunity to go back and forth with the program director. Some of the programs that's very helpful. In other cases, you might be able to move forward even without doing that back and forth. And then also carefully prepare the proposals. So for the engineering core programs, I'm just going to start off by giving you, I hope they don't come across as just sharing org charts, because the intent is really just to show you where some of the people are at NSF that could be very interested in your work. So keep in mind, your work might be interesting to a wide range of people, But we share these slides really so that you can see, oh, this team is focused on an area that's related to what I do. This program director might be interested in something similar. So that's the main takeaway that we're hoping that you can glean from some of these slides and then some of the key areas of focus. Keep in mind, you might have thought of something that we haven't thought of, so please feel free to reach out to any of the people in these charts who might be able to help steer your interest to somebody who could be working in your space. So the NSF Directorate for Engineering, so we have the Assistant Director, Don Tilbury. We also have the Emerging Frontiers and Multidisciplinary Activities. And then we have the Senior Advisor for Science and Engineering. And then within engineering, we have 3 disciplinary divisions. So these are the areas of engineering and technology. So you see CBET, Chemical, Bioengineering, Environmental, and Transport Systems, Civil, Mechanical, and Manufacturing Innovation, CMMI, and then ECCS, Electrical, Communications, and Cyber Systems. So you might be able to key in on your technology being relevant to one or more of those areas of technology and research. That said, we also have engineering, education, and centers, and also have industrial innovation and partnerships. So industrial innovation and partnerships really focuses on that translation from research to commercialization and market. And so some slightly different programs that are very related with the research that is done in these other divisions, as well as the outside market. So for CBET, as you can see, there are 4 different areas. So there's chemical process systems. You see a wide range of areas covered there. Engineering, biology, and health, environmental engineering and sustainability, and then transport phenomena. So I hope that you can all take a moment to take a look at this slide and maybe take note if there's anybody who you think might be closest to your area of expertise or interest, because it's certainly helpful to reach out to these program directors. So CBET areas of interest, chemical process systems. This is supporting fundamental research for the development of novel materials, mechanisms, or tools to improve efficiency, resource utilization, and or intensification of chemical processes. Engineering, biology, and health. So supporting engineering research to improve human health and the understanding of biological systems. Environmental engineering and sustainability. So really monitoring and mitigating the impacts of human activities, advancing resources, energy conservation and recovery. So many aspects of protecting the environment and human health. Transport phenomena, so supporting single multi-phase flow systems, particulate, heat and mass transfer, and combustion and fire dynamics. So CMMI, civil, mechanical, and manufacturing innovation. Again, just want to give you a moment and move a little slower so that you can see if there's anyone of specific interest in the organization. So initiatives ranging from advanced manufacturing, dynamics control and cognition, operations and design, mechanics and engineering materials, and then resilient and sustainable infrastructure. So just to highlight some of the areas of interest, and please, I'll read the slides for those that prefer to listen. And then if you prefer to read it yourself, of course, it's right here. Advanced manufacturing in manufacturing and materials processing, emphasis on efficiency, economy, sustainability, and scalability. Dynamic control and cognition, so modeling, analysis, diagnostics, measurement, and control of dynamical systems. Physical interaction between human and embodied artificial intelligences. Mechanics and engineering materials, so understanding the behavior of materials. Resilient and sustainable infrastructures, innovation to advance resilience and sustainability of the civil infrastructure. Operations and design, so decision-making aspects of engineering, design, control, optimization, and system science. Electrical communications and cyber systems has several areas, so communications, circuits, and sensing systems, electronics, photonics, and magnetic devices, energy, power control, and networks. So some of the areas of interest are at the nano, micro, and macro scales, underlying device and component technologies for power controls, networks, communications, computation, and sensing applications. Research on systems and networks for advancing engineering applications, and then education of a diverse workforce in electrical and computer engineering for the 21st century and global economy. Engineering education and centers. So there's centers and networks. So ERCs, Engineering Research Centers, Network for Computational Nanotechnologies, NCN. Engineering education with a number of programs. Engineering workforce development, and then broadening participation in engineering. And I do just want to say that there's both a dedicated broadening and participation in engineering in EEC, but this is also something that's very important to the foundation as a whole. So, we certainly welcome diverse participation, whether it's from underrepresented groups, different geographies, diversity of experience and expertise. So we will cover that a bit later in the presentation, but we really encourage you, please come to us, and we do welcome that diversity. EEC areas of interest. Broadening participation in engineering, so enhancing inclusion and participation in engineering by addressing structural inequalities and biases within educational and workforce systems. Centers and networks, so these provide the structure, coordination, and resources to solve engineering grand challenges and launch new industries. Engineering education, encouraging educational research to create and support an innovative and inclusive technological workforce for the future. And then engineering workforce development, so supporting pilot initiatives and meaningful research experiences that provide insight into concepts, innovations, and careers. Division of Industrial Innovation and Partnerships, IIP. So IIP invests in high-tech small businesses and collaborations between academia and industry to take discoveries from that research and development to impact in the commercial market or to have societal benefit. So there's a range of programs and centers that I'll go into in a moment. So what are the risks IIP addresses? So you may have heard people talk about the valley of death, or that gap between fundamental early stage research and then where the private market wants to invest. So the IIP programs really focus on trying to address that. So some of the risks or issues are gaps in education, how to accelerate something to market, how to demonstrate something works, and then how to translate it actually to the market. So there are a range of programs on the education side, so things like I-Corp, PFI, and Intern, some of which allow that engagement with the market and customer discovery. So many of you, you might have started businesses, or you might have advances in the lab that you're thinking about, well, would you like to explore it? So there are programs for you to kind of get a sense of whether it might be worth pursuing. I-Corp is also that acceleration with those customer interviews to see if it's worth pursuing further in a business. Demonstration of the technical side, you see that both in IUCRCs, PFI partnerships for industry, and then SBIRS TTR. So the SBIRS TTR, that's where there's active funding of companies. So startups that are really trying to take something that's an innovation and then commercialize it. And then the financial risks, again, which SBIRS TTR are trying to take on. So this is the org chart for IIP, members of the team and across different programs. So if you want to look here, there's the representation of many of our programs and experts. As I said, I-Corp, IUCRCs, SBIRS, TTR, and PFI. And we do cover in IIP the broad range of all technologies. So whether it's computational, biology, energy, AI, any area of technology would feed in to IIP in terms of if you're interested in taking that research to commercialization or exploring it. So next we'll do an overview of some engineering directorate solicitations. And again, these will be pretty high level, but we would encourage you to follow up with the different solicitations and program directors as you have interest. So we have a range of mid-size interdisciplinary engineering research. So a number of these. So Ascent, which is addressing systems challenges through engineering teams. So these are answering engineering challenges associated with complex systems and networks that are only achievable by interdisciplinary research teams. So if you have one of those interdisciplinary teams, this is a good one to look at. Environmental convergence opportunities in CBET. So this is really to try to confront these challenging environmental engineering and sustainability problems by developing foundational knowledge on underlying processes and mechanisms. The next one is Leading Engineering for America's Prosperity, Health, and Infrastructure. So this is addressing demanding, urgent, and consequential challenges through leadership and engineering. So we also have Emerging Frontiers in Research and Innovation, and these are solicitations that are really geared towards some very emergent new areas of research that get developed through the responses to that solicitation. So Emerging Frontiers in Research and Innovation. So two of the areas that have been funded are brain-inspired dynamics for engineering energy efficient circuits and artificial intelligence. So aims to understand and apply dynamical neuroscience to leverage the unique features of biological learning and decision-making for AI systems. And then also engineered living systems. So this is aiming to leverage the capabilities of living cells and organisms such as self-replication, self-healing, homeostasis, and environmental responsiveness to design, fabricate, manufacture, and model engineered living systems. We also have interdisciplinary centers. So ERCs, Engineering Research Centers, and then Industry University Cooperative Research Centers. So the fourth generation of engineering research centers, so the FY21 planning grants and the FY22 ERCs are underway. So 4 new ERCs that we had in 2020 were Advancing Technologies for Preservation of Biological Systems, Advancing Sustainability through Powered Infrastructure for Roadway Electrification, Quantum Networks, and then Internet of Things for Precision Agriculture. Your role as a researcher is invaluable to our innovation and research of the nation. So we're also very focused on supporting you throughout your career path. So there's both support at the undergraduate and graduate student level, postdocs and new faculty, mid-career faculty, and throughout your career. So we hope that you've potentially already received NSF support and that certainly you will come to us for future support where we can be helpful to you in your career and research. So for students, there's research experiences for undergraduates. Those are REU scholarships. Also research experiences and mentoring. So this is available in FRE and ERCs. Student design related to NSF research. Graduate research fellowships during the graduate work, supplemental funding opportunity for skills and training in advanced research and technology, and then non-academic research internships for graduate students. So early career, we have the Engineering Postdoctoral Fellowship Program, which is new, just recently awarded, and this is being set up with the first cohort in fall 2021. And then we have the Innovative Postdoctoral Entrepreneurial Research Fellowship. So if you're interested both in research and entrepreneurship, please look into that as well. Early career, so a new one is the Engineering Research Initiation. So this is to support new investigators as you initiate your research programs. And it's limited to those not affiliated with very high research activity R1 institutions. And the deadline's coming up quite shortly in June 18th. And then there's the Faculty Early Career Development Program, so the career program, which deadline is coming up in July. And we do host a career proposal writing workshop each year, if that's of interest. So for middle career, we have boosting research ideas for transformative and equitable advances in engineering. So this is trying to help experienced researchers and scholars, tenured or equivalent, to go into new directions with their research by branching out of their established knowledge domains. And then mid-career advancement. So this is enhancing and advancing research through partnerships. So the goal of these is really helping at that critical career stage where there's that goal to advance and ensure long-term productivity and creativity. So to kind of free up some of that opportunity to think outside of the box and try new things. The MCA has an opportunity to substantially enhance and advance research program through synergistic and mutually beneficial partnerships, typically at an institution other than the home institution. And it's great to focus on projects that envision new insights on existing problems or identify new but related problems previously inaccessible without a new methodology or expertise from other fields. So there's some good opportunities. So throughout careers, career life balance supplements, and that can always be important. And some of us have seen even more of that this year as we've faced. I know I've faced different career life balances meant a different thing in the past year than in prior years. But anytime this is really available to support additional personnel to sustain research when the PI, co-PI, or other member of the senior personnel is on family leave for primary dependent care responsibilities and other direct family considerations. And then also to support additional research, this could be a technician or a research assistant, to sustain research while a postdoctoral researcher or graduate student being supported by NSF on the award is on family leave for primary dependent care responsibilities or other direct family considerations. The re-entry to active research program. This is CBET and MPS CHE only. This is to catalyze the advancement along the academic track tenure of highly meritorious individuals who are returning from a hiatus from active research. So we hope that these are also meaningful areas of support for those that this is relevant for. We'll go next into engineering infrastructure and networks. So for research infrastructure, the main takeaway here is like mid-scale research infrastructure. These facilities and tools are for the use and education of the whole U.S. research community. So one example is the natural hazards engineering research infrastructure. So you can imagine the time that we're increasingly focused on the challenges and opportunities of extreme wind, water, and earthquake events. There are 8 experimental facilities, and there's opportunities for modeling, simulation, and computational tools to manage, analyze, and understand critical data. There's also the National Nanotechnology Coordinated Infrastructure. That's 16 user facilities for academia, companies, and government. So 2,000 plus fabrication and characterization tools and instruments. So access sometimes to those tools to really advance the ideas and the research can be helpful. The Network for Computational Nanotechnology. This is a cyber resource for nanotechnology theory, modeling, and simulation. So research and education content nodes in nanomanufacturing and nanobio. NSF includes, this is a very key initiative to enhance U.S. leadership in science and engineering by developing STEM talent from all sectors of our society. So this is forging cross-sector partnerships, disseminating needed resources, and enhancing capacity to create educational and career opportunities for underrepresented communities. So there's planning grants to build capacity for the development of collaborative infrastructure. And then there's participation in the Includes Network. You can learn about and share best practices with other leaders about broadening participation from education, science, industry, nonprofits, professional organizations, and government. And then you can also strengthen your personal capacity in areas such as strategy, measurement, communication, and program sustainability. And build a national community of supportive peers who are very committed to catalyzing STEM education and career opportunities for underserved populations. The FY19 total was $20 million, and we also want to extend the invitation of the network to anyone interested in improving diversity and inclusion in STEM, which is, of course, very important to all of us at the foundation. ERVA, Engineering Research Visioning Alliance, Future Research Directions. So this is obtaining and integrating input from those with interest in engineering research, including academia, industry, societies, government agencies, public, and then communicating coordinated information on nascent opportunities and priorities in engineering research to these stakeholders, strengthening connectivity across these diverse stakeholders and increasing coordination among engineering disciplinary communities. So this is really meant to serve to identify and develop bold and societally impactful new engineering research directions. So it's the pursuit of innovative and high impact research. So those research ideas that would align well with national and global challenges. Getting started. So, I think today is very much the beginning. I know it's very high level and quick going through many of the opportunities. So we hope that was more just a very high level roadmap to show you where some of the areas of interest and connection to your work might be. And then you're probably all wondering, how can we best position ourselves for receiving funding? So I'll just say the following guidance is going to, in some of these slides, is going to be very high level. And I would encourage you for a specific opportunity to really read the solicitations carefully. In some programs, there's also webinars or the ability to speak to, you could reach out to prior grantees perhaps. So reach out to program directors. So it is worth thinking on a solicitation specific basis, but I will just share some things to keep in mind. What should you consider? So you want to be bold in your ideas. You'd like to propose work that advances your field in leaps and bounds and has broad societal impacts. And then ask for the funds that you need to complete your work. For example, you want to make sure that you have sustainable wages, whether it's research assistants, graduate students, also the same for people in companies. Make sure you're asking for what is really required for the work to be successful, funding for summer salary, small to mid-scale equipment funding, and then keep in mind the duration of funding that's needed. As we've shared before, broadening participation is very much an important part of our mission. So please be aware of different opportunities for broadening participation. And then also keep in mind that it's important to us at the foundation as well. So please feel welcome to join and build the community. We encourage the training and mentoring of students, postdocs, and veterans, and encourage career life balance and varied paths and learning from colleagues. So we are your National Science Foundation, so we really want to be serving all researchers, all innovators, and all those who are committed to bringing technology forward for our nation. So here's just a screenshot. Again, we're just touching the tip of the iceberg with what I've gone over today, but you can go on our website and you can look to find funding. There's an A to Z index, so you can go through a wide range of solicitations. You can also try to search through your areas of interest. And then this is one of my personal favorites, which is if you are interested in seeing some examples of what the NSF has funded, you can do an NSF award search. You can click both active and expired awards. You can put in keywords of your area of interest. So that can be really quite helpful. And I would just say, if you don't see something, it doesn't mean that we're not interested in funding it. It might be that you're at the very leading edge. So it's more of a sampling. And of course, you build the future, and we hope to be there with you supporting your work. Submitting proposals before submission, you might want to seek advice from people who have been successful in the past, whether it's other researchers, people who are familiar with the process. Send a project summary, potentially call or visit the program manager. That really varies by program. So for some programs, that's important. And then for others, they might have other intake processes, such as I know in IIP, our first step for startups is a pitch as opposed to a call, but really try to get a sense of what that first step is in terms of the process, and then volunteer to be a panelist. And this is really a way also to pay it forward, and a tremendous way that you can contribute to our innovation and research ecosystem. So it's a great way to see inside the process, to really get a sense of how proposals are being assessed. It's always exciting to see the ideas presented, and just really quite helpful and a way to serve, and also good networking opportunity. So follow the program submission guidelines, and then the 5 elements of the intellectual merit and broader impacts, having a transformative potential, having a plan, including measures of success, team qualification, and involvement. So when you put people up on the team, how engaged are they really? And then having adequate resources. And something that I like to share is this piece about how are you really pushing it forward? When you think about what is so differentiated and a step forward about what you're doing, or why is it important to the contribution in your space, that's very helpful. And also, is there some new angle, some fundamental new knowledge that's really going to help things take off? So it's helpful oftentimes to articulate that well and make sure that you're able to get some of those strengths out, oftentimes right at the beginning of your proposal, although that can vary by solicitation. So think about the appropriate duration and budget for your project. Is it well justified? And understanding what that range and expectation of budget is for different proposals. So submitting proposals. After submission, please be patient. There's nothing that you can do at this point. There can be a wide range for how long it takes to get responses back. We like for them to be shorter waits, but sometimes they are longer. So please be patient. And then the panelists will provide guidance to the program manager. The program manager recommends awards. The division director concurs, and the Division of Grants and Agreement makes the grant to the PI or to the entity applying. It can be a university. In some cases, it's a company. But so that piece of just understanding it's a multi-stage process. We're really relying on the insights of reviewers to help inform that prioritization, but then there are several internal steps to the process in terms of getting to decisions. So if awarded, we really hope that you do great work that is impactful. And, again, there is also the reporting side to this, but certainly focusing on the impact. And then if declined, there is an opportunity in many solicitations to come back in the future. So we hope that you see this more as a long-term relationship where hopefully we'll be able to support your most compelling work going forward. So read the reviews, probably set them aside, seek to understand the reviews, and then you can determine how or when to resubmit or to come back in the future with something completely different, whether that solicitation or a more fitting solicitation. So please become a reviewer. We rely on your talent. You are the core both of the talent on actually bringing forth the proposal side and doing the work, but additionally in helping to assess the potential of the work of others that informs our process of prioritization. So it helps to understand the merit review process. It helps in terms of being able to write future good proposals. It may open up new opportunities to you in terms of how you think about your career or different opportunities in the future. It's interesting and leading edge work. It's a great way to network with other experts. It's a significant service to the science and innovation community. And if you would like to serve as a reviewer, you can reach out to program directors from any of the divisions. So those slides that I showed earlier on, if you see somebody who is specific to your area of research, you might want to reach out to that division directly. And then as I've shared IIP, on the business side, we take a look at all areas of technology. So if you think whether now or at some point in the future, you might want to commercialize something or be able to share insights with your students, please feel welcome to send an email to sbir@nsf.gov to serve as a technical reviewer. We can always find a a panel probably that aligns with your expertise. So we'd be very happy to have you there. We have many open engineering program director positions. So CMMI in operations engineering, in ECCS and energy power control and networks, and then IIP in partnerships for innovation. And I will just say that, there's a nice tie also between being a reviewer, if you're interested in also getting a sense of us. I was actually a reviewer before applying to be a program director. So, certainly we welcome your interest either in applying to us, submitting a proposal, or becoming a reviewer. And then there's many ways that we keep in touch. And so we're active in engineering on social media. And so please follow what we do. And we're excited to learn more about your innovations and your fundamental research in science. Again, we're very eager to support your curiosity-driven research and then also your use-inspired applications. So there's a space probably for almost everything that is being done that has potential to really move the needle, whether it's in the advancement of knowledge or in the practice. So now I just want to take a break and open it up for questions and answers. I've brought some colleagues along with me who might be able to go in greater depth. Would want to just share that in many of the more detailed cases, it will probably be necessary to reach out to the individual program directors, but we'd certainly be happy to respond to any higher level questions as we're able to. Thank you. Thank you so much for your time and good luck with your proposals.
Welcome back, everyone. Thank you, Anna, and thank you, Cecile, for answering lots of questions in the Q&A. If you did ask a question and you don't see it here, you might want to look in the answered section of the question and get your answer there. So what I'm going to do is I'm going to go through some of these questions in the time that we have left, and please, you can continue to submit them. I can't promise that we're going to get to all of them today, but please feel free to do that. And at least it gives us a sense of what you all are interested in knowing about. So I'm going to start with the ones that have been upvoted. And the first question is that there is a lot of overlap between the Division of Materials Research in our Mathematical and Physical Sciences Directorate and future manufacturing. So the question is, how do you define the difference between the programs in these two divisions?
So I'll defer to Cecile if she has better guidance, but I would just say in general, rather than getting, oftentimes in IIP, when we're thinking about where there could be overlap, it's really just that there's more opportunity to apply. So oftentimes the best approach is just read through the solicitations, see what looks like it might be applicable to your work, see perhaps what it's been funded on the NSF award search for that program. And you're typically able to apply to different solicitations at the same time. Of course, you give that information on what you applied to in your current and pending support form. So, we always make sure that there's no overlap. Certainly on funded work, but Cecile, if you have better guidance than that, please feel welcome to share it.
Sure. So I just wanted to make sure that everyone understood that the future manufacturing opportunity is one of those special interdisciplinary solicitations that a lot of parts of NSF participate in because they are related to their main research areas of interest. So the Division of Materials Research is definitely interested in manufacturing. It is a participant in that solicitation, as are other divisions in MPS and engineering and other parts of NSF. In fact, almost every directorate in NSF has a stake in that solicitation. So Anna's absolutely right that it's kind of a special opportunity, a bonus opportunity you get because it's an area that NSF is interested in pursuing more.
The next question is, are there projects in engineering that are available to support undergraduate students from underrepresented backgrounds?
So there's definitely the REU supplements. That's one that I can speak to, and that's for all undergraduates. And certainly we welcome broadening participation in all of our funding opportunities, not just funding opportunities that are specifically set aside for underrepresented groups. But Cecile, you might be aware of others as well.
Yeah, that is the main one that I can think of. I think there are other opportunities that that engineering collaborates on through the Education and Human Resources Directorate that support undergraduate students. So that's one. I'm sure we have a list somewhere on our website, which I can try to dig up for you and put in the Q&A. But there are quite a lot of opportunities where we especially encourage undergraduates from underrepresented backgrounds to participate. So.
Okay, and the next question is about success rates, I guess. And the question is whether does the success rate track in the engineering directorate track with the success rate of NSF as a whole?
I would say that success rates are really a function of a few things. So it's a function of funding levels. So, and, kind of one of these supply demand type situations where if you get a much larger volume of proposals, you have the same fixed budget, the award rate would be lower. So it's challenging to predict the exact funding rates, and it certainly does vary by solicitation based on that allocated budget and then the number of proposals that come in, and also the level of quality of those individual proposals, because sometimes there is flexibility depending. Some solicitations, some parts of the budget have flexibility, others do not. Cecile?
I'd say that's true. Absolutely. But there is a lot of variation among, different competitions and different parts of engineering and different parts of NSF. You can find some of that data on NSF's website. And I think, the main thing to focus on is writing proposals, trying to come up with a great idea for your proposal and submitting it when it's ready. And that's how you're more likely to have success with your proposal.
And then also just to remind everybody, for most of these solicitations over time, there is the opportunity to apply in the future. So in many cases, we do allow resubmission. So while you may or may not get funded the first time, oftentimes it's a learning opportunity. And some PIs find that they are successful in subsequent applications. So we would definitely encourage everybody, when you apply, if it's your first time applying, it's really the beginning of what we hope is a long-term relationship. We really value your contributions to the science and the innovation of our country. And we hope that when there's a project that is a fit for what we're interested to fund, that you do share it with us and that we're able to provide that support. So sometimes that's the first time around, sometimes it's a subsequent submission.
Okay, there's a question here that asks a general question about NSF decisions on fellowships requiring fellowship recipients to be U.S. citizens or permanent residents, and asking if this is a policy decision made internally at NSF or by Congress or some other means. I'll state that there is not an overarching policy for why a specific program may require a fellowship recipient to be a U.S. citizen or permanent resident. I mean, I would leave that's probably left best for the program to determine and make those decisions. I don't know if you have anything you wanted to mention about the engineering postdoc fellowship in particular with respect to this.
Well, Cecile thinks about that one. I will just share that it's probably not a one-size-fits-all answer. I mean, I can say certainly for what is a different solicitation for SBIR, TTR, which is small business funding, there are certain criteria to be eligible to receive that funding. And so that is SBA eligibility. And one of those elements is that a company needs to be majority owned by US citizens or permanent residents. So that's a very different program than what you've asked about with fellowships. But I would just say there are some cases where it is, not an NSF choice, and it is more of an eligibility requirement for the federal funding of a certain type. And
Right.
I can't speak to other opportunities.
Well, I'll also add that a lot of fellowships funding is made directly to the individual as opposed to the institution, which is for the majority of awards made that NSF makes. Those awards are made to the institution, and NSF does rarely make awards to foreign organizations. So just keep that in mind as well. A question about key differences between chemical process systems in CBET and chemistry. I'm assuming this is the chemistry division in the Mathematical and Physical Sciences Directorate.
That is a great question. And as somebody who my background is in chemical engineering and I'm an SBIR, I can say, I don't know what that precise comparison is. Also, sometimes that comparison changes over time based on what's coming in the door, what's really exciting in terms of the ideas that you put forth, who the program directors are. So I would just encourage you, go to the NSF award search, look at the recent awards. You can even look at them over time to see if there have been changes over time, and then see who's working on those different programs. And you might be able, they might have information that they've put out on their websites, or you might be able to send them emails. But I don't know, Cecile, if you have an exact answer to that.
No, I don't have an exact answer. But I know in a lot of the program descriptions in engineering, if you read to the very end, they sometimes will say, if this is what you're interested in, look at this other program, or if you're interested in this other thing, here's a different program. This comes up for a lot of our programs. They butt up against each other. The program directors talk to each other. So, and oftentimes, if they receive a proposal that's not really a fit for their program, they can transfer it to a different part of NSF. So I would absolutely encourage you to do all those things that Anna was just talking about to, try to understand what the programs are interested in and if your idea fits, but also if it's not a perfect fit, it's not necessarily the end of the world. And even in some of the program descriptions, you'll see that the program directors say, if it's outside of what we've written here, we might still be interested in it. So contact us. So, it's just, I think that's really the best way to go is to, look into it and try to talk with the program directors if you can, but also not worry about it totally because we do have flexibility in NSF to move things around.
And just if it's okay, Jeremy and Cecile, would you mind if I just quickly share the NSF award search screen so that people kind of know what we're talking about? So basically, again, I don't ever remember the link. I just look in a search engine for NSF award search. That's the actual link right there. I always go to the advanced search because that gives you more functionality. So you can search on any of these fields. So if you know a PI's name, an organization, that can be, it could be a lab, a university, it could be a company. You can search by the program officer's name. You can, I think it's often helpful to click both active and expired awards if you want, because some of our awards expire, 6 months or a year after they're issued. So you might want to do those. You can have start date and end date ranges, and then you put in a keyword. So let's say chemical processes. Well, let's come up with something. Let's say scale. We'll see. We're not going to say scale up because I'm not sure how that's going to search. But when you put in whatever keyword is of interest to you, it gives you so many results. And so then you can click the export as Excel file here. And then when you go into that, you're going to see all the abstracts, the contact information of the PIs. So this is really a great tool. It's going to also tell you who the program directors are. So, and the program. So that's a nice way that if you look at work that's similar to yours, you can actually see by going through that column of the programs, which programs might be likely to fund that. And also the program directors' names. So
thank you. That's great. That's a great tutorial. Thank you for doing that. The next question, and we get this a lot, and you covered it a little bit about how to become a panelist. But do you have some suggestions across the directorate, the engineering directorate, for folks who would like to become a reviewer, whether a panelist or maybe even an ad hoc reviewer?
Well, I think we always need great reviewers. We're very grateful for when you make that commitment. It's so helpful to us and to the innovation community. Hopefully, it's also helpful to you because it gives you that insight on what's going on. I would just say that the best thing to do is really to reach out to program directors who might be active in your space, or if you'd like to do it more broadly, as I said, industrial innovation and partnerships, we cover all areas of technology. So that that email address that was earlier in the presentation, you can reach out to that. And usually you would include your CV. I can't speak for the academic programs. In our case, we're usually looking for a 1 or 2 page CV because it's a lot to ask somebody to go through kind of a 20 or 50 page CV. But it's also probably helpful to add in that email 1 to 2 sentences to a paragraph on what areas that you think you could serve effectively as a reviewer for, because that makes it easier for them to say, oh, we'll have a panel coming up next fall, or they might be able to share your name with somebody else.
Okay, we've got time for, I'm sorry.
I just would add that that's consistent for the other programs in engineering as well. So.
Okay, yeah, we've got time for a couple more questions. The question is, where does digital health fit into engineering? Which part of the org chart that you showed would be most interested in multidisciplinary digital health research?
So Cecile might be able to add some additional programs, but I can confirm that we do in IIP have a portfolio in digital health run by my colleague, Alistair Monk. So, and I'm not sure if Cecile, if we might have something like that in SciSce or in other parts of engineering.
I'm trying to look it up right now, but there is a cross-directorate program that I think would be a fit, and I'll respond to that question once I find it. So.
Okay. The next question was, I guess you were talking about programs that were focused on technology development and transfer. And the question is, do the programs also fund UX and ethics research in those fields?
So the translational research is focused on, so SBIR, STTR, for instance, is focused on funding companies. So if a company were to have a business plan that was active in those spaces, it could certainly be considered. I imagine that there are other parts of the foundation where scientific ethics is perhaps one of the top things they do, but ethics can be a very important consideration, also in those translational proposals. And those questions definitely do come up in panel, whether there are ethics concerns or opportunities, but we don't frame it out as a separate segment, I guess, as far as I can tell.
Okay, and we'll take one last question here. The question is asking about the engineering research initiation program, and that it's the solicitation says that it's limited to investigators that are not affiliated with R1 institutions. But this person is saying that they've found several ERIs awarded to R1. So is there any way that you could explain how that might have happened?
I couldn't. So
I
that I
couldn't
wouldn't be able
either.
to speak to that. I'm
Yeah,
not sure
I'm
if Cecilia
sorry.
does.
I know with other awards, sometimes people change institutions. That's the only thing I could think of. I'm not really sure what happened in this cases that you found. But it is intended for people who are at non-R1 institutions.
Okay, I know we still have a number of questions there, but we're unfortunately not going to be able to get to them today. But I do want to thank Anna and Cecile for coming today and presenting and answering your questions. We'll be continuing this conference tomorrow afternoon. There will be sessions, 2 sessions tomorrow. So the first one will cover award management, or everything you need to know once you receive an award from NSF. And then there will be also a session on the Faculty Early Career Development Program, or the NSF Career Program. And I know a couple of people were asking about that. So again, I want to thank you for coming, and hope you enjoy the rest of the conference and have a great rest of your day. Thank you very much.